Great. Awesome. Thank you, Justin, for introducing me. My name is Alex Castillo. I'm a software engineer at Netflix. But today, I'm here to talk to you about my side project. So I build software to understand human behavior. And one of the sources that I base my research on is electricity. The human body is an ocean of electricity. Everything we do is controlled and facilitated by electrical signals that are running through our bodies. Well, today, I'm very excited to tell you that we're going to use JavaScript to witness some of this electricity in real time. But before I proceed, I will actually would like to get a volunteer that is going to join me on stage and is going to wear the nerdy hat. Anyone up for the challenge, just raise your hands. I have one here, two here. I see someone jumping there. I'm a little blind, but you can come. Yeah. Yeah. Thank you. Whoops. Whoa. What's your name, sir?
Hemant.
Hemant?
Hemant.
Hemant.
Numant.
Numant.
Yeah.
All right. Nice to meet you.
Same here.
All right. Please come here.
Oh, this looks crazy.
Take a seat. And I'm just going to put this on your head. You look like you don't have a huge head, which is a great thing, because sometimes this doesn't fit and people have to, exit. But
Hope this doesn't electrocute me.
electrocute you? We'll get to that part. Yeah. Shit. You scared me, man. All right, so you're going to feel a little bit of spikes, but we actually want that because those are the electrodes that are going to make contact with your head. Make sure. If it hurts, just let me know. It shouldn't. But yeah, you do have a good head for this headset. God bless your parents. So I'm going to put these earlobes here. Mm-hmm. That is just so your head doesn't explode. So just, okay. I'm going to turn it on. If you can just stand up real quick and turn it around so they can see that it's on. Okay. Just turn around. You're going to see a blue light. Take a seat, relax. And just so we're clear, I'm going to have pseudo access to your brain. Just relax and don't think of anything inappropriate, okay? All right. If you're not the guy for this, just let me know now. We can save you the embarrassment, all right? And I hope you got some time to read the fine print in here. If not, yeah. All right, so I'm going to take what is going to capture the signals from the headset, and I'm just going to plug it into my computer. Good. I'm going to exit my slides and just start running Node. All right, so I'm just going to run a Node app that I'm going to walk you through a little later, but what we want is to visualize. It's just going to take a few seconds. It's going to enter your brain, and we should start seeing something real soon if you have something on your head. All right. Of course, I should have turned this on after that, so let me just fix it real quick. All right. There you go. Are you comfortable there?
Yeah.
Awesome. I'm going to give this one more try. Oh. There must be something wrong with you, man. Exception. Yeah, for sure. There's something completely wrong with you. I'm going to try to fix something here and see. Are you thinking of something inappropriate right now? That would do it for sure. Oh no, man. Yeah, yeah. This is not great. I have to kill the process. It's your name, process. I'm not running anything else. Let's give this another try. Otherwise, I'll have to kill the process. Okay, I'll have to. What is the command again? Kill all node -9. No, kill all. Yeah, kill all. Uh-oh. Kill all node -9. Okay, this is the embarrassing part when I'm going to go to Stack Overflow. You know you all do this, right? You all do this. I don't know how many times I've had to do this before. All right. I knew it had a 9. I knew it had a 9. There you go. What I don't have is a PID. And I have to do a grep first. Yeah. Kill. No, you're making this very difficult. 11:01. 750, which one? Jesus. Where is it? Kill. And the PID is? 1050. Thank you. Thank you for your patience. But that didn't work. I'm going to give this another try. Otherwise, you're going to have to be honest with us. Again? Yeah. All right, give me 1 second. This one. Give me 1 second. Let's turn this one off. Plug this one in. Turn this one on again.
Is this running Windows?
Oh, no comment. Oh, there you go. Thank you, guys. You do have something. Great. Thank you for your patience. It's not easy interacting with the human brain with JavaScript. All right, so what we have in here, I'll walk you through, but first, let's just see the fun stuff, right? And let's start by checking out some actual brainwaves. All right, we are getting some signals in here. What I do see is that there are some channels that are not making contact with the scalp. That will be channel 1, 2, 3, 4, 5, and 6. Okay, so I think this one here. There you go. Don't move, okay? Just relax. If that one doesn't work, it could mean you have nothing on this area. I'm just being honest here. Let's see. These two are good. Is it a little tight? I think it's that. I think it's just way too tight. That means you have probably a white head. There's nothing wrong with that, though. Can you feel that?
Yeah.
All right, we have one. There you go. Now, one, two, three. 1, 2, 3. This one here. Almost, almost, almost. All right, I think we can proceed with what we have. Don't shut down that part of your head. Just, just think of beautiful things. All right, we'll work with those 7. Okay. All right, so this is some of the brainwaves visualized in what we call a time series. Oh, the contract is not great in here. But what you're seeing is the electrical signals being captured by the headset and being displayed in a web browser. And for the sake of time, I'm going to show you different ways we can visualize this. If my window would just... All right, this is fine. All right. Great, so I'm gonna stop it and run it one more time. Use server. Okay, I think I have to do the trick of stopping again the process. Let's see. 1050, 1172. It's okay. All right, this is good for now. I'm going to stop here and I'm going to walk you through what just happened, okay? So please give it up for our volunteer here. Thank you. Yeah, wait. Careful. Right.
Cool.
Thank you so much, man.
Thank you.
I really appreciate it.
Yeah.
All right. Okay, so what just happened here? This is what I called Neuro JavaScript. And what is Neuro JavaScript? Neuro JavaScript is not this keyboard helper at all. But it's a combination of some concepts, right? Isomorphic JavaScript is one of them. Neurotechnology, data science, data visualization, open source, and more. So I'm going to walk you through step by step how we came to visualize those brainwaves in the web browser. Okay, so the first thing we need to know is that here I have a headset. And that headset, it's from a company called OpenBCI. And the great thing and what makes this headset so special is the fact that this is completely open source and it's mostly 3D printed. So as you can see here, this is mostly plastic. What you see is in white and in red. This is all plastic. The other part of it is actually the board that is actually doing, all the computing, and then you have cables that end up in some sensors. And these sensors are called electrodes. These electrodes actually make contact with your head. And you can see here an animation of how it actually comes together. There's a lot of tiny parts. You can actually go to the GitHub repo, download all the 3D files, print it yourself, order the board separately, and just put it together and get up and running. The next part that I want to show you is the USB dongle. The USB dongle is this guy right here that is what actually connects via Bluetooth to this board. Then it gets to the computer, right, as it's plugged in, is USB, via serial port, and that is exactly where Node takes it in. And let me tell you a little bit of how Node takes it in. Just by doing an npm install for the OpenBCI SDK, you're able to start interacting with this. So what I've done, I've created a series of classes that abstract this process in order for me to use that data that you saw and start doing stuff with that. So I broke it down into some concepts. I have some connectors. And connectors, they basically transmit the data, right? And right now, the connector is like Bluetooth via serial port. I created an abstract class so you can choose from other connectors that might be available in the future. For example, maybe one of this dongle, maybe we can just connect via Bluetooth directly to the computer. Maybe we can just do it through Wi-Fi. Maybe we can do it with the next thing that comes out. Then we have providers. And these providers actually capture that signal, and they facilitate and they basically distribute it to our Node application. And then we have modules that they take this data, they transform it into different formats. One of those formats, for example, is a time series. Another format could be a fast Fourier transform. And I'm going to walk you through it. By simply just instantiating some of the connectors and signals, we can then start and instantiate and initialize our modules. In this case, we have some FFT, we have some topographic data that we're going to be, I might be showing you later, and then the time series, which is exactly the lines that I show you first. They all take the signal, which is the provider that I was talking about. And lastly, we can just invoke a method called stream that basically makes available the data, and we pass it to different providers like the signal provider or motion capture. Signal provider is that data that is sent to the front end. And for example, motion capture, in this example, this board actually contains accelerometer data. So that's something that we can also use. So you will get coordinates of like X, Y, and Z as you're moving the headset, which is something that you can also play with. You're going to be getting one sample every 4 milliseconds, right? Which makes a 250 sample rate. And a sample is what I show you from the Node terminal, and it looks something like that. The most relevant information here is actually the channel data. That is what has the signal from each different sides, each different part of your brain. So in here, we have 8, and that is what you're getting. Some of the actual nodes are just for comfort, so they sit on top of your head. The other ones are actual electrodes, and those are the ones that pick up the signal. aux data is the motion accelerometer data that I was telling you about. And then we have other type of metadata like the start byte, sample number, stop byte, etc. Lastly, we're using WebSockets from Node to send this data treated in the different formats that I talked about, FFT, topo, time series, and we use WebSockets to send it to the client, to the web browser. And in the example that I show you, there are many technologies that are being used. One of them is Plotly. We have smoothie charts for the time series. We have Three.js for some WebGL data visualizations that I'm working on. We have Chart.js. We have Angular 2, which is the actual app and what is putting everything together. The time series looks something like this most of the time on a very well headset that is calibrated and everything, and it has data coming from all of the channels. And I'm going to walk you through some code samples with Angular 2 that show you how you can capture this data from WebSockets and how to display it on the browser. So who has used TypeScript or Angular 2 here? Can you please raise your hands? All right, we have like a few people. Good. So I chose Angular 2 because I built the app using other different libraries, and Angular 2 was where I finally landed. It had great performance benefits that really helped me accomplish this in a way that was effective and scalable. So I'm importing some dependencies, including some components, the element reference, and some component lifecycle hooks. For example, the component is ready, and when it's destroyed, then I'm importing some dependencies for like a smoothie chart. So this example is going to show you that time series I was telling you about. And before I do that, I'm going to quickly try to run my simulated data. Right, so let's get if I see. In the meantime, let me keep showing you some of the code. This is an annotation that you can do with TypeScript, which is Angular 2 specific. You can see the add component, which basically points to a selector, which is like the BCI time series. We have a template URL, we have a styles, and we have some providers. The Angular 2 API has changed a little bit since then, but it's pretty much very similar. But if we're looking at the template of this, component, the most important part is that it has a canvas element. Because Smoothie.js, smoothie charts, uses canvas. So then you're going to see some Angular 2 specific syntax here, where you have the brackets for binding, and then you have the actual class definition, which is just an ES6 class that implements the onInit and onDestroy from Angular 2. Some dependency injection via constructor. And finally, then some data structures that we're going to be using in order to fill our data. So we have some smoothie chart containers for the time series. The amplitudes are the values that are shown to the right, the numbers changing positive and negative energy in microvolts. Then you have a timeline, which is the seconds that you have at the bottom, telling you exactly where in time that data is being expressed. And then we have lines, which are 8 lines from 8 different parts of our head. All of them, they map to a time series container. So when the component initializes, we're going to be calling a function that is going to basically initialize our smoothie data structures, and then we're going to be using socket.io to listen for events that are related to time. Once we capture those events that are related to time, what we do is that we get data back. So this is exactly the data that is coming from the server, but piped through the connectors, the providers, the signals that I told you about, that are basically massaging the data to be kind of like front-end friendly. So we're not sending a data event to the client every 4 milliseconds. We actually have a buffer in Node that we're aggregating a certain amount of data. I think probably every 64 samples, and then we're passing it through some filters, and then we're sending it to the front end. Okay, calendar. So once we get that data, we replace the amplitudes object. This amplitudes is basically what we're binding to in our template. So amplitudes is an object that we have in our template, and we can have that data available for us to basically semantically express. We have a timeline, which is basically an array of seconds, and then we're appending timelines. When we append timelines, here, we're just going for each one of those channels, in this case 8, and we are basically appending a data point, right? In this case, a line. That is what we're calling it, a line. So each one of those 8 lines, they directly correlate with this part here. So each time we receive an event, we go through each one of the channels, we're appending with the current date and time, right, with the current time, and we're passing an amplitude. That amplitude is just that data set that I told you about from here, from each one of the different channels. And in this case, when we're adding the time series initially, right, that function that I show you right here, we're just making sure that they have a stroke style that map to the color that we want to use. In this case, it's just a list, an array with 8 different colors, so we can classify it by color. Something that is very important to mention is that because there's going to be a lot of events being received by the client, on the browser, it is very important that if the component is actually not being displayed in the application, basically, when it fires the onDestroy event from the Angular 2 component lifecycle, we need to make sure that we remove that event listener. Because if we have all these events still lingering from other components that are also showing data visualizations, then it's going to overwhelm the browser, it's going to probably freeze. Ultimately, this is just a little bit of more Angular 2 templates that shows how to do a repeater. In Angular 1, it was like an ng repeat. In Angular 2, we have an ng4. And then we have a more ES6 style type of declaration here when you have let amplitude of amplitudes. And that is exactly the amplitude element that is being shown to the right. The same for the timeline. We're iterating through each one of the timeline elements that we have. I believe in this case like 18. We're actually using an HTML5 time element with a dametime attribute that basically formats that time into seconds, into readable human seconds. Great. So that being said, I want to talk to you about this project a little bit. I've been taking this in phases. Right now, this is just phase 1, which is simply visualization, right? And we've put a lot of work into just making sure we can visualize brainwaves, but there's so much more that we still need yet to do. Second phase is going to be about experimentation, so we can actually take that data, do something useful with it, right? And I'll give you a few examples. Ultimately, interpretation, which is really just reading thoughts. I believe this is possible, and I believe that each one of you with your JavaScript skills could get to contribute or to be part of something as big as this. This is why all of this work that I've shown you today, including the hardware, everything is open source and very affordable just to put together a simple headset. This is just an example of some experiments that other people have done. This one is not JavaScript specific, but there's nothing that is actually stopping us from starting to control things and doing things with our current skills here. Imagine you can control a user interface with this headset. Maybe someone is disabled and now has the ability to do something with their computer. And there are so many other things, including like maybe controlling your wheelchair, accessibility for the web, and actually just getting to know ourselves a little better. Think about it, all the data is right here, and we struggle with knowing ourselves sometimes. But I think now we have the power to take that information and do something meaningful with it. So I encourage you to get involved. There are many, many meetups about NeuroTech. I used to go to one in New York City, but there are in many parts of the world. The GitHub repo that I've been doing all this work in is NeuroJS. In there you can find exactly what I showed you today, that whole app. And there is an OpenBCI community. It's not JavaScript specific, but it's NeuroTech oriented. and everyone is welcome there. So that being said, please keep in touch and let me know if you have any questions. Let's give this another try. I came from very far, and I'm not gonna let a cold or jet lag get in the way. So thank you for joining again. Let's see how it goes. All right, so we have only one channel that is not really connecting well. That's just 1, 2, 3, 4, 5, 6. The 6, which is probably I think he doesn't have anything on that side of the head, but these are the real brainwaves that I meant to show you. So, thank you. So here you can see to the right, you can see the voltage, and you're gonna see that fluctuating between positive and negative values, because that's the way electrical signals work. They don't mean anything, like positive energy is not worse than negative energy. They're just going to fluctuate. So something else I wanted to show you is actually the frequency. When you pass a signal to a fast-forward transform, this is actually the frequency. This is not like going in time. This is actually in real time the way the frequencies translate. So the channel, let's see, the yellow one is channel 6. That's the channel that we were not getting anything from. That's what you can see is stale, right? And towards the middle, you're going to see around this area here that things don't change much. Is because in that part of the frequency is being picked up by like some even like the background noise. So
Background noise in the music or in my head?
yeah, just like the ambience, right? Like your body is receptive to that, so it's actually going to be transmitted. So you can see some of that.
So if I think something like if I think that I'm running or I'm being chased by a dog or something,
Yeah.
will the graph change?
Well, so some of the yeah.
Should I try that?
And also, it's worth mentioning that this headset in particular is also going to pick up some MEG, which is like the muscular signals. So let's do a little experiment. Try blinking a couple of times.
One eye or two?
2. Try blinking a little harder, yeah. Yeah, so you can see some of that being picked up around here. It gets very interesting when you start seeing the frequency categorized by different frequency bands. So if you're familiar with like theta, alpha, and beta, I can tell you, for example, according to some experiments, if you want to measure hunger, according to some doctors, some of the delta band is going to get lower, and some of the alpha and the theta is going to get higher, right? So this is also used to like measure progress when it comes to like concentration and meditation. Yeah.
Take a screenshot.
Take a screenshot.
Yeah.
There you go.
Thanks.
This is just another way of showing frequency in a circular type of layout. So try clipping your jaw like if you were like chewing something. You can see that being okay. You can stop now. You can see that actually being manifested here.
Ooh.
Yeah.
That's cool.
Yeah. But whatever you do, just don't fart, because you can really tell from this. Yeah. Okay. Thank you guys.